Hi, I'm Jaleel, and today we're going to master the full life cycle of a firm's operational decisions by bridging chapters 6 through 9. Now, instead of going through abstract variables, instead we're going to apply this to the real world business of logistics and fleet management. For example, we will be going through the life of an independent courier. In order to move packages, a logistics company relies on two things. One will be labor, which will be using L as a variable. This represents our driver's main hours. And two will be capital, which K will represent the variable for capital. And that's also the fleet of our cargoes. In the short run, our fleet size is completely fixed. So say if that fixed size is 5 cargo vans, right? If we keep hiring more and more employees, then we'll encounter the chapter 6 core rule, the law of diminishing marginal returns. Eventually, adding more workers to a fixed asset means drivers will sit idle while waiting for a vehicle. And because of the marginal product of labor, eventually adding more drivers to a fixed asset means drivers sit idle waiting for a vehicle, which literally can cause the marginal product of labor to decline. But in the long run, both our fleet size and our driver count can change. Now let's look at how we minimize the cost to scale efficiently. All right, ladies and gents, let's look at the exact algebra behind optimizing our resources. Suppose our delivery production function is the standard Cobb-Douglas model. Now, at the top right here, we got Q equals KL squared, where Q is the number of weekly corporate delivery contracts we fulfill. Now, let's assume that each unit of the cost couple. Now, in this scenario, let's just assume that the unit of capital is 20 an hour and that the unit of labor is 25 an hour. And our fleet is fixed at 5 vans, which is K. So now that we're deriving our short run total cost curve, we now know that the total cost equals fixed cost plus variable cost. And now that we're plugging in our equation, now the number of weekly corporate delivery contracts equals the fleet L squared, and then that turns into, if we flip the equation around, that turns into L squared equals the contracts divided by the fleet. And then that also turns, because we're trying to turn this into a squared, this now becomes L equals the contract squared divided by 25. Now, after we plug in all the numbers for the short run total cost, this now turns into, the short run total cost now turns into 100 plus the weekly contract squared. And now the fixed cost is exactly $100, while our variable cost is the contract squared. Now the equation is the short run average cost equals the short run total cost divided by the contracts, which can equal 100 divided by the contracts plus the contracts. Now, as for the marginal cost, the equation is marginal cost. The equation is marginal cost equals DTC divided by DQ, which can equal 2Q. To explain the graph a little bit more, when we plot these curves, the short run average cost is U-shaped. Now you're wondering why. It's because the low levels of output causes our $100 fixed cost to spread thin over very few units. Now, at high levels of output, the diminishing returns start to kick in, which can drag the productivity down and drive the variable cost up. Critically, our MC curve will always intersect our short run average cost curve at its absolute minimum point, which happens right here at Q10 units. Now, let's bring in chapter 9, profit maximization. In a perfectly competitive logistics market, our firm is a price taker. We don't set the price, the market dictates it. To maximize our total profit, we must produce where the market price equals the marginal cost, which is P equals MC. If the current market price for courier contracts is P equals 30, then we set that at 30 equals 2Q, which means our profit maximization input or output is Q equals 15 contracts. But what if the market conditions collapse due to intense competition or a drop in demand? Or if the price drops to $15? At this point, we are losing money because the price is below our average total cost. Do we shut down instantly? So no, you don't exit. Instead, you run by the short run shutdown rule. This states that the firm can keep operating in the short run as long as the price covers our average variable costs. And in this example, if the average variable cost is 7.5, which is $7.50, $15 is still above $7.50. So technically, you can keep running as long as that number, like the cost that dropped or whatever, as long as that number is above the ACV, you can keep running the business. So if we were to be technically speaking, if we understand the paths of raw inputs to short run cost structures, business owners can make a perfect data-driven decision whether they want to keep scaling the business or cut down costs or want to exit the market. And that's pretty much it. Thank you guys so much for watching this video, and I look forward to seeing your videos as well.